Good evening, my dear Senior 1 students. Our lesson today in algebra is the relation between coefficients of a quadratic equation and its roots. If L and M are the two roots of the equation ax squared plus bx plus c equals 0, then sum of the roots will be negative b over a, and product of the roots equals c over a. Direct example number 1, find sum and product of the two roots of equation 2x squared plus 5x minus 12 equals 0. So here sum of the roots negative b over a, which is mean negative 5 over 2. Product of the roots equals c over a, which is mean negative 12 over 2, gonna be negative 6. Example number 2. If the sum of the two roots of the equation 2x squared plus kx plus 1 is negative 3 over 2, then find the value of k. So here sum of the roots equal negative b over a, which is mean negative k over 2. So negative k over 2 equal negative 3 over 2. Crossing 2 is 2, so k equal 3. Example number 3. If the product of the two roots of the equation 2x squared minus 4x plus k equals 0 is 4.5, then find the value of k. Since here product of the roots equals c over a, which is mean k over 2 equals 4.5 means 9 over 2, crossing 2 is 2, so k equal 9. Let's take some notes. If one of the roots of a quadratic equation is additive inverse of the other, then b equals 0, which means some of the roots will be equal 0. And if one of the roots of a quadratic equation is multiplicative inverse of the other, so their product equals 1, which is mean a equals c. Example number 4. If x equal negative 1 is one of the roots of the equation x squared plus kx minus 7 equals 0, find the other root, then find the value of k. Here you have a equals 1, b equal k, c equal negative 7. So product of the roots c over a, which is mean negative 7 over 1, it will be negative 7. You have one of the roots is negative 1. Negative 1 times second root equal negative 7. So second root equals 7. And you have sum of the roots negative b over a, negative k over 1, which is mean negative k. So the sum of the roots negative 1 plus 7, it will be negative k, which is mean k equal negative 6. Example number 5. If x equal 5 over 3 is one of the roots of the equation 9x squared minus 9x plus k equals 0, find the other root and then find the value of k. You have here sum of the roots equal negative b over a, which is mean negative 9 over 9, gonna be 1. So one of the roots 5 over 3 plus the second root equals 1. So the second root 1 minus 5 over 3, which will be negative 2 over 3. Product of the roots c over a, k over 9, and the two roots are 5 over 3 times negative 2 over 3. So negative 10 over 9 equal k over 9, crossing 9 with 9, so k equal negative 10. Exercise number 6. If negative 1 and 5 are the two roots of the equation ax squared plus bx minus 5 equals 0, find the value of each of a and b. We have here product of the roots equals c over a, which is mean negative 5 over a. And the two roots negative 1 and 5, so negative 1 times 5 will be negative 5, equal negative 5 over a. So from here a equals 1, you get the value of a. Sum of the roots negative b over a, so negative 1 plus 5, it will be 4, and negative b over a, which is mean over 1. So negative b over 1 equal 4, which is mean that b equals negative 4. Exercise number 7. If x equal root 2 plus I is one of the roots of the equation x squared minus 2 root 2x plus c equals 0, where c belongs to R, find the other root and the value of c. Since the coefficients a, b, and c are real numbers, and one of the roots is root 2 plus I, which is mean complex number, therefore the other root is its conjugate, which is equal root 2 minus I. And sum product of the roots equals c over a, which is mean c over 1, equals root 2 plus I times its conjugate root 2 minus I. Root 2 times root 2 equal 2 minus I times I is I squared, and I squared, as you know, that it's equal negative 1. So C will be 3. Experiment number 8. If one of the roots of the equation 3x squared plus k minus 3x plus 7 equals 0 is additive inverse of the other root, then find the value of k. As we take in the notes, if one of the roots is additive inverse of the other, so their sum equals 0, which is mean b equals 0. So k minus 3 equals 0, so k equals 3. Exercise number 9. Find the value of z that makes one of the roots of the equation x squared plus dx minus 5 equals 0 is double the additive inverse of the other root. If we suppose that the first root is L, so the second root is double its additive inverse, which is mean negative 2L. So their sum L plus negative 2L will be negative L, and then product L times negative 2L will be negative 2L squared. Sum of the roots, which is mean negative L, equal from the rule negative b over a, which is mean negative d over 1. Crossing negative with negative, so L equal d. Product of the roots equal c over a, which is mean negative 50 over 1, equal negative 2L squared. So L squared equals 25, and L equal d, so d squared equal 25, taking square root for both sides, so d equal positive or negative 5. Exercise number 10. Find the value of k that makes one of the roots of the equation 2kx squared plus 7x plus k squared plus 1 equals 0 is multiplicative inverse of the other root. Since one of the roots is multiplicative inverse of the other, therefore c and a are equal. So k squared plus 1 equals 2k. Moving 2k to the left hand side using the other sign, so k squared minus 2k plus 1 equals 0. This is perfect square trinomial. We can factorize it as k minus 1 all squared equals 0, which is mean k equals 1. Exercise number 11. Find the satisfying condition that makes one of the roots of the equation ax squared plus bx plus c equals 0 is double the additive inverse of the other root. So here, if we let that the first root is L, the second root will be negative 2L, as he said, double the additive inverse of the other root. Their sum L plus negative 2L will be negative L, and their product L times negative 2L will be negative 2L squared. Sum from the rule is negative b over a, so negative b over a equal negative L, crossing negative together, so L equal b over a. Product of the roots equals c over a, so negative 2L power 2 equals c over a. So negative 2 and replacing L and write instead of it b over a. Negative 2b over a whole power 2 equals c over a. So negative 2b squared over a squared equals c over a. Crossing 1a from here and 1a from the left hand side. So negative 2b squared over a equals c. Crossing multiplication. So negative b squared equals ac. Moving 2b squared to the right hand side using the other sign. It will be 2b squared plus ac equals 0. This is the condition. Example number 12. Choose the correct answer. If the opposite figure represents the curve of the function f where f of x equal ax squared plus bx plus c, then b plus c over a equals. You know here that the two roots are 2 and 5, the intersection of the curve with x-axis, so their sum equals 7 and their product equals 10. Sum of the roots is negative b over a equals 7, so b over a only is negative 7. Product is c over a equal 10. He wants b plus c over a. Separate the expression, so it will be b over a plus c over a. Negative 7 plus 10 equals 3. So the answer, the choice number A. Next one. The product of the roots of the equations ax squared plus bx plus c equals 0, bx squared plus cx plus a equals 0, cx squared plus ax plus b equals 0 equals. We know that product of the roots equals c over a, which is mean the numerical factor over coefficient of x squared. From the first equation, it will be c over a. From the second equation will be a over b. Third equation b over c. and their product will be 1, so the answer choice number C. If x1 and x2 are the roots of the equation ax squared plus bx plus c equals 0, and 0 greater than x1 smaller than x2, and absolute x1 bigger than absolute x2, which of the following statement could be true? So here, since x1 will be negative because it's smaller than 0, and x2 is positive greater than 0, and here absolute x1 bigger than absolute x2, so here the sum of the roots will be negative sign. So the sum negative b over a smaller than 0. And product of the roots, one is negative, one is positive. So the product is also negative, so c over a smaller than 0. So sum and product, each one of them is negative. So if I multiply sum of the roots and product of the roots, the answer will be of positive sign, which is being greater than 0. So negative b over a times c over a bigger than 0. It will be here negative bc over a squared bigger than 0. You know that a squared will be positive. So by multiplying both sides by a squared, the direction of the inequality doesn't change it. So negative bc bigger than 0. Divide by negative 1, so bc smaller than 0, which is mean choice number C. Thank you, my student, and see you soon.